All right, so let's take a look at lesson 2 here. So lesson 2 is going to take us from what we did in lesson 1, multiplying with polynomials, and making it so that we're now looking at how we can actually divide them. So the first thing we want to do here is the opening exercise. So the opening exercise is asking us to multiply out two different polynomials. We should be able to do this if we totally understood lesson 1. So go ahead, pause the video and try lesson exercise 1 here, this opening exercise. I'm hoping if you're back with me at this point, you've paused the video, you've taken a look at this problem, and you've tried it on your own. Let's see if you get the same answer that I get. I'm going to go through this kind of quickly because guess what? You should have learned this in yesterday's lesson. Okay, so we have all of our different multiplications coming out here, and we're looking at what are some things that are like terms. All right, so across from each other, we have our like terms. Right, 10 and 5, that adds up to 15x squareds. 25 and 2, that adds up to 27x's. So our final answer is a cubic. So we have the cubic 2x cubed plus 15x squared plus 27x plus 5. Look at that nice little answer that we have here. So here's our job for today. Today, we want to be able to work backwards. We want to start with this answer, which we call a quotient. Right, so we want to start with the quotient and come up with whatever the divisor was, right? Or come up with what was the two things that multiplied together to make that quotient. So we already know a lot about multiplication. We know multiplication is going to be able to be undone by division. We know division is able to be undone by multiplication. So if we have a division problem, there's underlying multiplication that's happening here. Meaning we should be able to use this same tabular method to use for a division problem in a little bit of a different way to be able to do it the same way or similar as the multiplication problems we did in lesson 1. So let's take a look at this same exact problem. Looks very different, but we're multiplying these two things together again. However, we already know the quotient, so let's pretend that we don't know what this is. Right, if we don't know what that is, what would I do if I knew the quotient, but I wanted to know what that multiplier was? Well, I'd start by one of the things that we know. We know I'm going to multiply one thing by 2x and 5. What else do we know? We know the first number, or the first term. The first term goes in this first box. Just like when we multiplied the first terms together, we got the first term of the product. Well, now that I know the product, I can say, well, I know that number goes there. Well, if I know that, what multiplies by 2x to make 2x cubed? So essentially, we have a link here. Whatever this number is going to get multiplied here to make this number, or this term. I keep saying number, I should be saying term. So what multiplies by 2x to make 2x cubed? Well, that would be just x squared. Because I would add the exponents, that would give me the x cubed that I want. And I would have the 2, because we already have the 2, so we're good to go. Well, use your puzzle skills. If I know that term, I know 5, I now know this box is 5x squared. However, from what we know about multiplication, I know these two things have to add up to something. What do they have to add up to? They have to add up to 15x squared. We knew that. It's almost the same as what you just did in the opening exercise, because it is. It's the same problem. So use your puzzle skills. If I have 5 and I want to make 15, I have to add 10. Well, if I know 10 has to be in that box, and I already have 2, what multiplies by 2 to make 10? That would be 5. What multiplies by x to make x squared? Well, that would be x. And I have another piece to my puzzle now. 25x, because 5x and 5 makes 25x. And I know these have to add up to 27, because it's here. So if I have 25 and I want to add to 27, I would have to add 2 more in. Well, what multiplies to 2x to make 2x? Well, that would have to be 1. Leave me with 5, and that's the last number, so we are good to go. So what is all this telling me? Right? After doing this whole multiplication problem as a division problem, I'm getting my answer. This is the answer, or we call it the quotient, right? We know what the division problem is giving us as an answer. Now, I don't want to write it like that. I don't have any pluses or minuses in there. So I'd show my answer as x squared plus 5x plus 1, which we already knew because I already told you. Now, this problem is a little bit easier because I've already given you all of the information. That's not always how it's going to look. So let's take a look at one where we don't know what the answer is, like this one. So reverse tabular method tells us that we have to come up with this same quotient here. So this is what we're trying to create in the boxes, right? Whatever number is on top, right? This is what we have to put in the boxes. So all three of those things have to be in those boxes, whether they're by themselves in that box or there's multiple boxes that add up to that term. And I've already kind of set this up for you. So I'm taking what's being divided by, x minus 2. I'm making that one of the two pieces. Because remember, whatever this is being multiplied by whatever this answer is over here. All right, so whatever we want in this top, that's going to be my answer. Now, we already know the first term has to be 2x squared. Has to be. Meaning the title or the top of this column is what multiplies by x to make 2x squared. That would have to be a 2 and an x. 2x times x makes 2x squared. Now use those puzzle skills. If I have 2x and I multiply it by negative 2x, I get negative 4x. However, I want to add up to positive 1x. That's what I want to be here. So now I have to think, what do I have to add to negative 4 to make positive 1? Well, that would be 5. So 5x. Well, if I make 5 the top of this column, what would that leave this last number to be? It should be 10, negative, negative 10. So what does all this tell us? This answer is 2x plus 5. Meaning if I was to multiply 2x plus 5 and x minus 2, I should get 2x squared plus x minus 5. The process is pretty similar, it's pretty straightforward, but there is some room here where things can get a little bit funky. So let's try another one. Example 3 says to create your own table and try the reverse tabular method to find this quotient. There are a lot more terms here, so we got to be careful, right? So let's start by making our boxes. The last one, the box was made for us, so we have to try and figure out how am I going to make this box happen, right? So one of the things that we should notice here is there's a missing term, right? We are missing the x term. Now in math, if something's not there, that means there's 0 of them. So when I start making my boxes, right, so I want to make my boxes, not really sure how many columns I'm going to have yet, but I do know I'm going to have 3 rows. I'm going to have a row for x squared. I'm going to have a row for 0 x's, and I'm going to have a row for 1. I want to fill in that missing term because that missing term is going to allow us to have our like terms all be across from each other like they're supposed to. And again, I'm not 100% sure how big this is going to be, so we're just going to kind of guesstimate for now. So let's make our first column. What term has to go into this first column? Well, that would be x to the 4th power. Why? Because it's the first term of the polynomial I'm dividing by. Has to be that number, or that term. So what multiplies by x squared to make x to the 4th? That would be x squared. Meaning I should be able to fill in this whole column using our skills of multiplication. X squared times 0 is 0, x cubed. X squared times 1, well, that's just x squared. Anything times 1 is itself. So now we have to make our next term. Well, our next term is 4x cubed. So whatever this box is and this box is have to add up to 4x cubed. So I know I have at least another column here. If I want to make 4, and I already have 0, I have to add 4. 4 plus 0 is 4. Well, if that's 4x cubed, I'm now asking myself, well, what multiplies by x squared to make 4x cubed? That's going to be 4x. Little trick, the exponents should start to go down, right? They shouldn't go up and be all over the place. 4x times 0 is 0. 4x times 1 is 4x. All right, so I've used this one. Now I have to make 3x squared. So all my x squared terms have to come together. 3x squared. Well, if I add 1 and 0, that only gives me 1. But I want to make 3. So I have to add 2 more x squareds. What multiplies by x squared to make 2x squared? Well, that would be 2. I'd have 0, and I'm going to have a 2. The next thing I should be able to add up to is my 4x, which I do, and the 2. So everything has been completed in this numerator. As soon as the numerator is completely completed in your boxes, you are done. So this answer is x squared plus 4x plus 2. So when I divide it here, I get a quotient of x squared plus 4x plus 2. All right, let's keep going. All right, so right below here it says, explain how we can use the previous quotient to factor this expression. Well, if two things multiply together to make an expression, those two things are also known as the factors. So if I was to factor this expression, I could take the two things that we used, right? So I could take the original item that we divided by, x squared plus 1. That's going to be one of the factors. I could take the next thing that we found was a multiplier, x squared plus 4x plus 2, that's the other piece. So we have x squared plus 4x plus 2. Whenever two things multiply together to make something else, those things are called factors. So these are my factors. So you can see how we're going to eventually start to use this in this course. One of the things that you spent a lot of time on in algebra was factoring. We're going to spend a lot of time on factoring in this class as well. So let's try another one here, okay? So let's go through this one. Doesn't have a missing term, so that's nice. We already kind of know how this is going to start out. So we have a 3x and a negative 2. So we know how many rows we have. Again, I'm not ever really sure how many columns I have. There's a rule that you could use, but we'll just kind of go with I'm not sure. What multiplies by 3x to make 9x to the 5th power? So 3 times 3 would make the 9. X to the 4th times x would make the x to the 5th power. Now you think about it, I have that. So that means I also know this bottom box is going to be negative 6x to the 4th. How many x to the 4ths do I want? I don't want any. So if I have negative of something and I want to get 0 of that, I want to add 6 to it. Positive and negative, that's going to add up to 0. Because there are no x to the 4ths here. There's a 0 here, right? There's a 0 there. So we want to make sure that we have that 0 accounted for. Well, that's 6. 3 times what makes 6? That would be 2. X times x to the 3rd would make x to the 4th. 2 and negative 2 make negative 4. So we wind up having this negative 4x to the 3rd power. Well, how much x to the 3rd power do I want? Right, so these two boxes have to make 11 x to the 3rd power. So what could I add to negative 4 to make 11? Well, that would be positive 15. What multiplies by 3 to make 15? That would be 5. What multiplies by x to make x cubed? That would be x squared. Positive 5, negative 2 makes negative 10x squared. Well, how many x squareds do I want? I want 31. I want negative 31 x squareds. I already have negative 10, so how much more do I need? I need negative 21 x squareds. What times 3 makes negative 21? That would be negative 7x. Negative 7, negative 2 makes positive 14x. Well, I don't want 14x's, I want 17x's. So what has to be added to 14 to make 17? That would be 3. Anything times 1 is itself, and then we have negative 2. Nice little check. This last number should always be the same as this last number. If it's not, you added or combined like terms wrong in some way, shape, or form. So, what's my answer? I have 3x to the fourth plus 2x to the third plus 5x squared minus 7x plus 1. We have this nice little quartic polynomial. All right, so here's your your reverse tabular division problems. All right, I hope this video helped. All right, there's 2 on your own questions here. If you choose to try them, you can come up to me next time you see me in person. I'll tell you if you got them right or wrong, and then we can go from there. Hope to see you soon.